Today's honors geometry lesson is on section 7.5, Inscribed Angles. The objectives are to define and solve problems involving inscribed angles. An arc intercepted by an angle is the arc of a circle that lies in the interior of an angle. The arcs outlined in red are arcs intercepted by the given angle. So for angle 1, here is the intercepted arc. For angle 2, here is the intercepted arc. Angle 3 has an intercepted arc of right here, and angle 4's intercepted arc is right here. So each time you're going to notice that the intercepted arc is in the interior or on the inside of each angle. An inscribed angle is an angle that has a vertex on a circle and whose sides contain chords of the circle. So using the same diagram, which of the angles below are inscribed in the circle? If we look at angle 1, we can see that the vertex is on the circle and both sides of the circle are created by chords. Therefore, angle 1 is considered an inscribed angle. Angle 2 also has a vertex that lies on the circle and whose sides are created by two chords of the circle. Therefore, angle 2 is also an inscribed angle. Looking at angle 3, we can see that the vertex does not lie on the circle. Therefore, angle 3 is not an inscribed angle. And angle 4 does have a vertex that lies on the circle, but you can see that one side is created by a chord and the second side is created by a tangent. So therefore, angle 4 is not an inscribed angle. Theorem 7.7 states the measure of an inscribed angle is half the measure of its intercepted arc. So based on the diagram, let's find why. The first thing we want to do is we want to locate the intercepted arc. So here is our vertex that is on the circle. Here are the two chords that create the angle. So therefore, the arc created by those two chords is going to be our intercepted arc. So if the measure of an inscribed angle is half the measure of its intercepted arc, it means that the intercepted arc must be twice that of the inscribed angle. So if the inscribed angle is 50 degrees, the intercepted arc is going to be twice that amount, which is 100 degrees. Corollary 1 states that inscribed angles that intercept the same arc are going to be congruent. So let's go ahead and prove why the angle of 50 degrees is going to be equal to the angle measure of x degrees. So if we again locate our intercepted arc, so here is our vertex that is on the circle. Here are the two chords that create the sides of the angle, and therefore, if we find the intercepted arc in the middle, it's going to lie right here. So based on that theorem 7.7, if the intercepted arc is going to be twice the amount of the inscribed angle, then this arc is going to be 100 degrees. If we go ahead and locate the intercepted arc for angle x degrees, we can see that if we extend the sides out, that the endpoints are going to be exactly the same as the other angle. Therefore, it shares the intercepted arc of 100 degrees. So if the intercepted arc is 100 degrees, the inscribed angle is going to be half of that, which means that x is going to equal 100 divided by 2. So x is going to equal 50 degrees. Corollary 2 states if a quadrilateral is inscribed in a circle, its opposite angles are supplementary. So if we have the following quadrilateral and we have one angle that's 102 degrees, the opposite angle x is going to be 180 minus 102 degrees, which means that x is going to equal 78 degrees. The last corollary that we're going to take a look at today is corollary 3, which states an angle that intercepts a semicircle is a right angle. So if we locate the intercepted arc for angle x degrees, so again, here is our vertex that lies on the circle. Here are the two chords that create that angle, and what you're going to notice, the two endpoints actually lie on the diameter, which means that that angle is going to be half of the semicircle, so half of 180 degrees does give us an x value of 90 degrees. The last theorem we're going to talk about today is Theorem 7.8, which relates to the first four angles that we talked about. We talked about how angle 1 and angle 2 are inscribed angles, but we also talked about why angle 3 and angle 4 were not inscribed angles. But this angle is going to look a lot like angle 4. So this angle was the one that was created by a vertex on the circle with one side as a chord, and then the other side is a tangent. So Theorem 7.8 states that the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. So here is our vertex, here is our tangent, here is our chord, which means that the angle that creates this intercepted arc is going to be half the measure of that intercepted arc. So then the intercepted arc must be twice the measure. So if we take 99 degrees times 2, we now know that this angle measure is 198 degrees. Okay, so x equals 198 degrees. So at this time, go ahead and stop the video, work through the examples, and when you're ready to see the answers, go ahead and start the video back up. So here are the answers to the examples. If you did not get the correct answers, again, stop the video and rework the problems. If you're still unable to get the correct answers, make sure that you bring any questions that you might have to the next class. So this brings us to the end of our lesson. So if there's any portion of the lesson that you need a review on, watch the video for a second time. And if you have any questions, especially on the last examples, make sure you write those questions down and bring them to the next class.